Hi everyone, it's time for our continued adventures with L'Hopital's rule, and we're looking at a specific shortcut that you can use, and it's when you're looking at limits involving infinity, like if you're at the limit as x goes to infinity. The thing you want to do is to look at the order of magnitude, and you might even be just going, what? And that's the what's growing the fastest. So, like, for example, an exponential function, like e to the x or b to the, any number to the power of x is going to grow faster than any polynomial. So remember, polynomial is something, so like x to the e to the x or 5 to the x, etc. for the exponentials. For polynomials, you're talking about that a x to the n plus b x to the n minus 1 plus however long. And no matter what is on the exponent, like an e to the 0.000001x will grow faster in the long run than x to the 9,999, or even a bigger number. So, and then a polynomial is going to grow faster than a logarithmic. So if you have natural log x, for example. So if you know what is, if you can look at the order of magnitude and what's growing faster, if you have a higher order over a lower when you're going to infinity, that's going to go to infinity because you have, more growth in the numerator. And if you used L'Hopital a bunch of times, eventually that bottom one would probably just go to some number, perhaps. Or if you switch that around, you're looking at the limit as x approaches infinity of a lower order of magnitude over a higher order of magnitude. I'm not going to write order of magnitudes out because it's too long. That would go to 0 because say you have like an x over an x cubed. If you use L'Hopital on that, you would get a number on the top and still have x's on the bottom. So if you have the same order of magnitude, that's when you're going to go to a finite limit. So if we're going to, as x goes to infinity, if you have the same order of magnitude, I'm just going to write same on the bottom just for sake of speed. That guy is going to go to a finite number, just something that's between 0 and infinity. Obviously, it could be negative as well. So, for example, we had this problem in our last video where we were going to infinity and we had 5x squared minus 3x plus 2 over 6x squared plus 11. So the highest exponent in both of these is the 2. So we have the same order of magnitude, and we did go to a certain number, And notice also, the limit on this is 5/6. Look at the coefficients on those x squareds. Coincidence? I don't think so. Because what happens is if you use when you use L'Hopital, like the 2 and the 11 go away they're gone right away. The 3x ends up going away too, and eventually you're just left with, essentially, it's like if you squint, you're really just left with 5x to the second over 6x to the second in terms of like really what matters. And really that ends up being 5/6 because you could cancel those x squareds out. So that's kind of what's happening. I'm simplifying that a bit. So if you have that same order of magnitude though, you're going to get a finite limit and you can tell in a hurry. So this is a really nice way to do things because you can very, very quickly find a limit without having to work very hard for it. So let's look at a couple examples. So if we have the limit, oops, I better slide that guy up. So the limit as x goes to infinity of, say, e to the x over x to the 100. Like if I use L'Hopital, I would have to use L'Hopital a lot of times to get that x to the 100, 100 x to the 99 and then x to the 98, blah, blah, blah. And the numerator would still just be e to the x. So it ends up saving us a ton of time, and we can look at that and go, oh, e to the x grows faster than x to the 100. So this guy's going to go to infinity. If I flip that upside down, so I have x to the 100 or even 1,000 or 10,000 or however big, it really wouldn't matter. If I use e to the, over e to the x, if I use L'Hopital a ton of times, eventually I would have the numerator down to a number, and then the denominator would just be e to the x. So a number divided by big, that's going to 0. And remember, even if you have like polynomials, you might go, oh, well, that's the same line. Isn't that the same order of magnitude? Well, no, not necessarily. Because what if you have something like x cubed plus 3x over x plus 1? That numerator has a higher order of magnitude. If I used L'Hopital on that, I would just have a 1 in the denominator, and I would definitely be going to infinity. Or if I flipped that upside down, I'd be going to 0. And then last quick example, like say we had natural log, the limit as x goes to infinity of, say, 2x to the 5th plus 7x to the 4th plus 9x plus 11 divided by 1 plus 2x plus 3x squared plus 4x to the 3rd plus 5x to the 5th. And I was a little sneaky on that. I switched my order around. But if you look at that, really this comes down to just the 2x to the 5th and the 5x to the 5th. If I use L'Hopital, the rest of the stuff would go away. And so my limit on this guy, I don't have to work very hard for it. My limit is 2/5. It's pretty convenient. So that's our shortcut. You look at the order of magnitude and you say, what's growing faster, top or bottom? If the top's growing faster, you're going to infinity. If the denominator is growing faster, you go to 0. If you have the same order of magnitude like we have here, we go to a finite number. So fancy, fun shortcuts with L'Hopital.